Hey guys, thanks for joining today's session. Today's session focuses on the measures of spread and their significance in data analysis. So, as part of this, we'll explore the measures like range, standard deviation, coefficient of variation, IQ or interquartile range in depth. So, understanding of the measures of spread is very much important as they provide insight into the data variability. And also through informative case studies, I will illustrate the practical application of these measures. By the end of this session, you will have a comprehensive understanding of range, standard deviation, coefficient of variation, IQ or percentile, and so on. Let's begin our exploration of measures of spread and their practical applications. To start with, let us understand what is measures of dispersion. What is measures of dispersion? So it is nothing but understanding how spread out the given data is. Whether the data is heavily, the wider, whether the data distribution has a wider spread or closer spread. So as you can see here, in this image, right, you can see that there are three data sets, A and B and C. There are three data sets all there. When you plot the three data sets in histogram or something like that, it looks something, the shape is something like this, a normal curve. This one is a normal curve. And this one, for the normal curve, the average will be there in the middle, the mean. Okay, and I have another distribution. So I said this is a data set A, and it is a normal distribution. Okay, it is also called as a bell curve. So in this case, almost all the values are somewhat close to your mean. Okay, the spread is not too wide. Whereas if you look at this second data set, which is nothing but this one, the spread is too wide. Okay, wider spread. Here you can see the closer spread. And I have another data set. And if you see that data set, it is much more wider than this. This is C. Okay, so as part of measures of spread or dispersion or variability, we wanted to understand how close the spread is, how close the spread or how far the spread is. What is the spread? So is it too wider or too closer? So what am I going to do by knowing whether it is a closer spread or wider spread? That we'll discuss it a little later. Now let us understand what is the difference between measures of central tendency and measures of dispersion. The difference between these two are, right, the central tendency tells us the center of the data. Center of the data. For example, you want to find out the mean. So it tells, the mean is there in the middle. Okay, the center of the data, you can find out with the measures that are available as part of measures of central tendency. But the central tendency does not tell us anything about the spread of the data. We need some measures which show whether the distribution is small or large. We need some distribution which should show whether the distribution is small or large. So that is where the measures of dispersion plays an important role. Okay, the simple example is, for example, if you know the average depth of the river, that is not sufficient, right? You should be knowing how the values are, how the depths are varying in different parts of the river. The average may be less. For example, the average is just 4 feet or 4.3 feet. Okay, 4.3 feet, the average depth of the river. But if you go different parts of the river, some places the depth will be more. Hence, knowing the average alone not sufficient, you should be knowing the variation, right? So how much it is varying it from one place to another place, right? So the one place to or different place of the river, you should be knowing that. When you plot it and if you draw it something, it will be like, this is called a distribution. And if the distribution is too wide, then that means, there are a lot of volatilities there. Somewhere it is too low and somewhere it is too high from our average. Hence, knowing the average alone not sufficient. If you know only the average, and based on which, if you decide to cross the river, you are in trouble. And especially if your height is less than 4.5 or so. Okay, so as part of this, we will explore the various measures such as range, standard deviation, variance, and the coefficient of variation, and IQR also. To start with, let us understand what is range. Range is one of the measures using which we can find out how spread out a given data set is, using which we can quantify the dispersion or the spread of the data set. A range is, we can compute the range by taking the difference between the maximum and the minimum value. That is what your range. Okay, and the formula is very simple here. For example, in my data set, the minimum value is 20 and the maximum value is 100. If I subtract the 20 from the 100, what you get is 80. That is what your range. This is what your range. So using this range, using this range value, right, we can quantify the dispersion, how spread out the data is. For example, let's take another. So this is my data set A. In the data set A, I have different values are there. The maximum value is this one, the minimum value is this one. I have another data set where the maximum value is 100, the minimum value is, this is 60. Okay, and if you compute the range, you get 40. So the 40 and 80, the difference is too much, right? It is double the time. Which one? For the data set A, the range is 80. That means, right, the spread is too wide. The spread is too wide for this data set. For this data set, the spread is not too wide. Okay, just 40, but whereas it is 80 in the case of the first data set. Okay, let's assume that this is your data set A and this is your data set B. Okay. Okay, this is how you can compute the range. Okay, and there are limitations with range measures there. Range measures are there. The one is it is sensitive to outlier. If you have an outlier in a data set, it shows that your spread is too wide. So for example, in the previous case, look here. In this case, we have an outlier here. Maybe the 100 is an outlier or 20 is an outlier. The distance between these two are too wide. Okay, so in this data set, let's assume that 100 is the outlier or 20 is the outlier. Let's think 20 is the outlier. Okay, and if you subtract the 20 from this one, you get 80 here. Whereas in this data set, most of them are somewhat closer to your mean. So hence the spread is just 40 only. Let's take another example. The same. Okay, let's take this example 40. Let's say in an exam, in a quiz, the score in a quiz, a guy took test 5 different times. Each time he scored 40. In the first time he got 40, and second time 82, 86, and 88, and 92, and 100. And if you see, majority of the time his score was good, and only one time there was an exception. This is kind of an outlier. In this case, if you find out the range, so the minimum is 40, maximum is 100 minus 40 is 60. If you exclude 40, let's say you don't have 40 at all, what is the spread? So the 100 minus 82 is 18. So the 60 tells us the spread is too wide, even though it is not too wide. See, majority of values are close by. Just because one value is very less, okay, it tells us the spread is 60. It's too high. If you exclude this one, and if you compute the range 100 minus 82, that is your 18. Since you don't have outlier here, it shows the real picture. the spread is actually not much. Just because I have an outlier in my data set. Earlier it was showing that 60, it was 60, right? It was too wide, whereas this is the reality. Almost all the values are close by. Just because I had an outlier in my data set, it was making me to think the spread was too wide. Actually, it is not. Okay. If you remove the outlier, you can see this. So with this example, we are able to understand quickly the range is sensitive to outlier. It mislead you to think your spread is too wide if you have outlier in your data set. And also it ignores the intermediate values. It does not taking into account of each and every value. Simply it takes into account of only the minimum value and maximum value. That's it. And also it lacks the distribution information. The range will not give you the insights into the shape of the shape or distribution of the data. It does not indicate how the data is spread across the range, or whether it follows a specific pattern or so. That is another limitation with range. Next, we will take a look at how to compute the range. That's what we discussed already. So if you subtract the minimum from the maximum, you can get the range. Okay, everything is good. So what are the applications of range? For example, let's take a simple case study. Let's compare two different distributions or data set. For instance, Sony, they assemble TVs in North and South Chennai. The arithmetic mean hourly output is both in North and South is 40. Let's say 50. In this case, it is 50. I'm going to say 50. So Sony, they manufacture TV, or they assembles TV in both. This is my North Chennai and this is my South Chennai. Okay, but here if you see the arithmetic mean, the mean hourly output is the 50. The mean output is 50 here. With this, we can conclude that the distribution of the hourly outputs are identical. That's what we can see, right? Here also, on an average, they manufacture 50 TVs in both the manufacturing North and South division, or the manufacturing unit. But if you look at the data set here in the North Chennai, the production varies from 48 to 52 assemblies per hour. We just think that, okay, per hour, 48 to 52. Whereas in the case of production at the South plant is more erratic. It ranges from 40 to 60 per hour. Okay. The range in the hourly production for the South plant is 20 TVs. So if you subtract the minimum from the maximum, what is the maximum? 60. What is the minimum? 40. 20. You get 20 here. Okay. And here, what is the output here? So here in this case, the maximum is 52 and the minimum is 48. And if you subtract 40, so you have just 4 only. The variation is not much. Higher the range tells us higher the variation. The spread is too wide, or the spread is, here, the variability is more, whereas the variability is less here. So in this case, the hourly output for North has very less dispersion. The dispersion is nothing but the spread or variation is very less compared to the South. That is what we can make out with this simple case study. With this, you can say quickly, in the case of South Chennai, the manufacturing unit, the the production is not good, right? So sometimes it is good, and it varies from 40 to 60. Too much of variation is there. Okay, so to summarize, so we understood what is range is all about and why we need to use range. Okay, so we use range. We explored that with the help of range, we can quantify the spread of your data set. And also we've explored the limitations of range. So one limitation is it is sensitive to outlier. The other one is the other one is it ignores the intermediate values, and it lacks the distribution information. And also we have seen how to compute the range and what are the application range we have seen it so far. Next one is